Inside Science.
At the start of October, President Trump said he tested positive for COVID-19, and his doctor said his treatment included an experimental drug called Regen-CoV-2. Regen-CoV-2 is a cocktail of two antibodies, both of which bind to the surface of the SARS-CoV-2 virus. In theory, this stops the virus from entering human cells and multiplying, thus decreasing the severity of the disease. But when the president was treated, there was no peer-reviewed evidence that the treatment would actually work. Now, the company has published research in animals investigating just that. Macaque monkeys were infected with SARS-CoV-2, then given the Regen-CoV-2 antibodies. Treated monkeys harboured less virus than untreated ones, and when the researchers examined their lung tissue, they found less damage and fewer signs of pneumonia. The researchers then tested the treatment on hamsters, who get a more severe form of COVID-19. But here, there was a bit of a mystery. Treated hamsters had less pneumonia in their lungs, but showed no significant change in the amount of virus in their system. So the study is interesting. It shows this treatment can work in animals, preventing lung damage, but that we still don't fully understand how. The researchers suggest that maybe the antibodies are acting in another, unknown way to have this effect, and that's perhaps a little unnerving. But overall, this is good news in the struggle against COVID-19. Good news that we're in need of, especially those of us in the Northern Hemisphere. A group of Norway-based scientists have published a model that predicts COVID-19 cases will continue to rise into the winter, peaking in December and January, if we don't make adequate interventions. The scientists based their predictions on data from the first 4 months of the pandemic, and they find that, surprisingly, the factor that correlates best with the lower infection numbers is the amount of UV light, rather than the heat of those summer months, which actually slightly boosts viral growth. Come winter, and less daylight, and the model suggests the virus will be back with a vengeance. But although there are, quite literally, dark days ahead, there is one upside. The pandemic has led to the biggest drop in carbon dioxide emissions in over a century. An international team of researchers found that emissions have fallen twice as much as they did after World War II, mainly because of decreased vehicle use, because people are travelling less. And speaking of CO2, another climate study has found that humanity could absorb almost half of the carbon dioxide pumped into the air since the Industrial Revolution, by restoring only 30% of the world's damaged ecosystems. The project mapped out all areas in the world that had been converted from their original ecosystems into cropland or pastureland at some point in the past. Then they asked which areas would most benefit climate and biodiversity if restored, without impacting agriculture. 30% was the magic number. The only issue is that these projections don't take into account national borders. So taking advantage of this climate restoration plan would require some slick international agreement. But these kinds of ecosystem restoration projects can work spectacularly. In 1933, slime mold and hurricanes wiped out the seagrass in the coastal lagoons of Virginia, and it never came back. But in 2001, conservationists established a program to re-sow the sea with seagrass seeds. And this month, they've published the results of that work. After sowing 74.5 million seeds into the ocean, almost 14 square miles of previously barren seabed has returned to seagrass meadow. The water has become clearer, carbon and nitrogen have been drawn down out of the atmosphere, and the ecosystem has become even more rich and diverse than in the neighbouring natural seagrass beds. Scallops from the area have even started spreading out, turning up downstream, carried by the currents. And for me, saving this kind of biodiversity is the great prize of conservation, because we have so much still to learn from the living things on this planet. Take this, the diabolical ironclad beetle. This beetle's exoskeleton is so strong that it can withstand being run over by a car and resist the bite force of its predators. But only this month did we find out why. The plates of the diabolical ironclad's exoskeleton have special ways of joining. They can interlock together like jigsaw pieces, which gives the skeleton its incredible strength. Or they can slide over each other, which allows the beetle to squeeze into small spaces. After finding this out, The entomologists then 3D printed artificial jigsaw joints like the Beetle's and found they were tougher than standard interlocking joints that humans might design. Borrowing this technique from the Beetle could allow us to engineer tougher, mechanically superior materials than we do today. Now, one thing I haven't mentioned this month is the Nobel Prizes, only science's most prestigious awards. But unfortunately, I've run out of time. So, if you want to find out about the gene-editing, virus-illuminating, black hole-exploring Nobel laureates, then check out these stories on the Inside Science website. But for me, that's it for this month. Stay safe. Goodbye.
Inside Science. If you enjoyed this edition, follow us on the web and social media. Powered by the American Institute of Physics and a coalition of underwriters.